Hi students, in this video I'll be going through the 2019 O-Level Mathematics paper 1 question 20. Alright, so this is a question regarding similar solids. Okay, so let's read the question. Okay, so the diagram shows two geometrically similar bottles. Okay, so the diameter of the base of the smaller bottle, so this is the smaller bottle on the left, is 4 cm, and the diameter of the base of the larger bottle is 10 cm. Okay, the height of the larger bottle is 30 cm. And okay, so for part A, okay, they want us to calculate the height of the smaller bottle. Alright, so let's take a look at the diagram. So I've transferred the diagram to the bottom. Okay, so over here, they told us that the height of this larger bottle over here. So if I were to draw the height, okay, from here all the way down, okay, to here. Okay, this height is 30 cm. Okay, so they asked us to calculate the height of the smaller bottle. Okay, so let's call this HS. Okay, then this one will be HL. Okay, so we are given a HL. Okay, and we are asked to find HS. Okay, so over here we need to ask ourselves, what is the relationship between the ratio of the heights of the bottle and the ratio of the diameters of the bottle? Okay, because the diameter of the bottle is the info that was given to us initially. So the diameter of the small bottle is 4 cm. The diameter of the larger bottle is 10 cm. Okay, so to answer this question, all you need to do is actually to look at the needs of the quantities that we are dealing with. Okay, so you can see that height is also a form of length. That's why the unit is in cm. Okay, it's not in cm square or cm cube. Right? Cm square will be for area, cm cube will be for volume. Right? Okay, so you can see the unit is cm, right? So the power is actually cm to the power of 1. It's not square or cube. Okay, so which means that both height and diameter, okay, they are actually a form of length, right? Okay, so for similar solids, okay, the ratio of corresponding lengths is going to be equal. Okay, so this means that you don't have to do any squaring or cubing, okay, to form any relationships over here, right? Okay, so what they want us to do is to find the height of the smaller bottle. Okay, so usually my practice would be to write the quantity that they want you to find right on the top left hand corner of the equation. Okay, so what do I mean? Okay, so I want to find the height of the smaller bottle, right? So I write HS over here. Okay, the height of the smaller bottle over the height of the larger bottle. Okay, so since both quantities are lengths, right, the ratio of corresponding lengths, okay, are equal for similar solids. Okay, will be equals to the diameter of the smaller bottle over the diameter of the larger bottle. Okay, so this is the equation that we formulate over here. Okay, so there's only one quantity that we don't know, which is HS, and which is what we want to find. Okay, so we'll just put in the values for all the other three, and then we can calculate out easily, all right? Okay, so HL is 30 cm. Diameter of smaller bottle is 4 cm. The diameter of the larger bottle is 10 cm. Right, so this is what we have. Okay, then we can find HS. So HS will be 4 over 10. Okay, so what I like to put at the top left corner is because when I want to calculate it, all I need to do is cross multiply this 30 cm in the bottom upwards only. Right, so I'll get this. Okay. Okay, so if you calculate out, you will actually get HS equals to 12 cm. Okay, so the height of the smaller bottle is going to be 12 cm. Okay, so remember, if you are talking about a ratio of height, it's going to be equals to the ratio of diameter because all these quantities are lengths. Okay, and if you forget, you just look at the power of the unit. So C is just cm, it's not cm square or cm cube. Okay, so if it's just cm means it's cm to the power of 1, right? That means it doesn't require to do any squaring or cubing. Okay, when formulating the equations for the relationship between the ratios. All right. Okay, let's look at part B of the question. So the smaller bottle has a capacity of 125 ml. Okay, so now over here we are told the capacity. Okay, 125 ml. Okay, so capacity also means volume. Okay, capacity also means volume. Okay, the manufacturer makes another geometrically similar bottle, okay, that holds 500 ml. Okay, so I think there's a word missing over here. Geometrically similar bottle, okay, that holds 500 ml. Okay, so this is not the same bottle. Okay, this is not the same bottle as the bottle in the part one. It's not the larger bottle, it's another bottle. Okay, so maybe we just call this the medium bottle. Okay, the medium bottle. Okay, calculate the diameter of the base of this bottle. So now they want you to calculate the diameter of the base of this bottle. What's the diameter? Okay, so now we are talking about volume. Okay, so volume, if you recall, ml also means cm cube. So this is 500 cm cube, the volume. So now you see the power is a 3, right? Here is a cm cube. Here is a, okay. So which means that when you formulate the equation, you will need to cube the ratio of the diameters in order to equate it to the ratio of the volume, right? Okay, so same thing. What we want to find is the diameter of the base of this bottle. Okay, let's call this dm. Okay, diameter of the medium bottle. Okay, let's call it dm. Okay, so the relationship, let's form. Okay, so same thing. Whatever you want to find, put at the top left hand corner. So dm over ds, okay, will be equals to volume. Okay, so volume of the medium bottle over volume of the smaller bottle. But remember over here we have cube. Okay, the relationship cube. Okay, you always cube the length. Okay, the ratio of the length, not the volume. Okay, because remember ratio of length, the unit for length is cm only. Okay, when you cube it, you get cm cube. That's where you equate it to the ratio of the volume. Okay, so let's put in the values. So dm over diameter of smaller bottle is 4 cm. Okay, then you have the cube. Okay, then this given as 500 over 125. Okay, so before you proceed to do anything further, always simplify this fraction over here. So if you simplify it, you actually get a 4 only. Okay. Okay, so 500 over 125 is 4. Okay, so now we want to solve for dm, which means that we will need to cube root on both sides. Okay, so cube root on both sides, so you will get this. Okay, then all you need to do is multiply the 4 up and you'll be able to find the value of the diameter of the medium bottle. So dm will be 3 root 4 times 4. Okay, so this will give you 6.35 cm. Okay, to 3 significant figures. Right, so not too difficult. Okay, so all you need to do is to know clearly okay, the relationship between the ratio. So if it's just everything is a type of length, then the ratio will just be a direct ratio. Okay, there's no need to cube or square anything. If it's a ratio of volume area, then ratio of then you will use ratio of the length square equals to the ratio of the area. If it's ratio of the volume, then you use ratio of the length square. Ratio of the length cube equals to ratio of the volume. Okay, so it's important to keep in mind, they may also ask you about mass. Okay, so mass will also be cube because mass is directly proportional to the volume. When the volume times 2, the mass also times 2. So ratio of the length cube will also give you the ratio of the mass, right? Okay, so do keep in mind all these relationships for questions like this.